Okay, for topic two, we're going to look at pictures of fractions. How can we visualize fractions? Because if you can visualize fractions and understand, hey, this fraction looks like this thing, or this picture represents this fraction, or I can represent a fraction on a number line, what would it look like on a number line? That's going to go a really, really long way in understanding what we're going to do in the future section. So visualizing fractions really quite important. Okay, so for example 4, it says determine the fraction that represents the shaded region of each picture. Okay, well, if we look at part A, we have this single circle. Okay, we can see that the circle has been split into 1, 2, 3, 4, 5, 6, 7 pieces. And we already know that the denominator is how many equal sized pieces we're considering. So our denominator here is going to be 7. Now, the directions very clearly say what fraction represents the shaded region. So let's go back. We're going to renumber. Okay. Of those 7 pieces, how many are shaded? Well, we have 1, 2, 3, 4. So we would have 4/7 shaded. Now, just for fun, what fraction represents the unshaded region? Okay, so the region that's not got color added to it. So if we were going to look at the unshaded region, we have 1, 2, 3 pieces out of 7 total. So 3/7 is unshaded. And if you think about this, we have 4/7 shaded, 3/7 unshaded. The combination of the two is 7/7 or one whole figure. Okay? Now, let's look at part B. So right off the bat, I'm like, whoa, I've got 2 pictures here. What does that mean? So a situation like this would be representing an improper fraction. Remember, by definition, improper fractions are fractions where the numerator is greater than or equal to the denominator, okay? So they have a value of 1 or more. So in this picture, you can see we have one whole shaded figure, and then we have a portion of another shaded figure. We're going to have some kind of improper fraction here. So the first thing we have to do is look at each individual image, okay? Each individual piece here. So we have circles. So each individual circle, how many pieces are they broken into? Well, we have 1, 2, 3, 4, 5. We also have 1, 2, 3, 4, 5. So we know that our denominator is going to be 5. Okay, we're looking at fifths here, or fifths here, however you say it. Okay, so now let's count how many of these images. So looking at these 2 images, how many of these little triangular pieces are shaded? So let me do a little erasing really quick so we don't get confused with our numbers. Okay. Now looking at just the shaded ones, so the ones that are the orange-red color, we have 1, 2, 3, 4, 5. That represents one whole, 5 out of 5. But on the next circle, we have 6, 7, 8. So the fraction here that represents the shaded region is 8/5. Okay? So just understand that when you have improper fractions, you're going to have more than one whole thing. When you have proper fractions, you're going to have part of one whole thing. Okay, so that is one way that we can visualize fractions. In this next example, example 5, we're going to flip it on us. We're going to take a fraction and draw a picture that represents that fraction. Okay, now when it comes to drawing pictures for fractions, I'm asking you all to limit yourselves to circles and rectangles. Don't try to do triangles. Students try to get really creative and use triangles, but it's really hard to split triangles into equal size pieces. And remember, when you're dealing with a fraction, the denominator represents the number of equal size pieces that figure is going to be broken into. So please stick to circles and rectangles. I generally do rectangles because for me, they're a little bit easier to draw. Okay, so 3/8. Let's see, 3/8 is definitely proper. Okay, proper fractions, remember, are always less than 1. So that means you're only going to have one figure and only part of it will be shaded. Okay, so we're going to draw one rectangle. Now, technically, when you're doing this, you're supposed to break this into exactly equal size pieces. But when you draw anything freehand, I can already see that my rectangle's a little, it looks like the wind is tilting it a bit. Okay, you want to draw your figures as neatly as you can, but no, I'm not going to pull out a ruler and measure. We can't freehand things and make them super precise, okay? Try to make it as even as you can, try to draw it as neatly and clearly as you can, but no, I don't expect it to be perfect because we're freehanding this. So we want to try to make it look nice. So if the wind is tilting your rectangle too much, maybe start over. But here's my rectangle. So this is my whole. Now, because my denominator is 8, I need to split my whole into 8 even size pieces. That's really important. So I'm going to go ahead and split it down the middle long ways, pretend it's exactly perfect. I know it's not. And then I'm going to split it down the middle this way, and then each half in the middle again. So I now have 8 equal size pieces. I know they're not exactly perfect, but do the best you can to make them close to perfect. Okay. Now the numerator is 3. So that tells me I'm interested in 3 out of these 8 pieces. So I'm going to shade 3 out of 8. So this right here equals 3/8. Okay. Now for the next one, we've got 7 halves. And so 7 is definitely bigger than 2, right? So this tells me this is an improper fraction. And remember, improper fractions are greater than or equal to 1. Well, since 7 is more than 2, this tells me this is definitely going to be greater than 1. And what that means visually is I'm going to have more than one figure. So if I use rectangles, I'm going to have more than one rectangle. Those rectangles individually have to be split into 2 pieces. So let's get started. So let's start with one rectangle. I'm going to split it into 2 pieces. And remember, we're going to shade 7 halves. That means we've got to have 7 shaded pieces. So I've got shaded piece 1, shaded piece 2. Well, I need 5 more, so let's keep drawing. So I'm going to draw another figure that is the same shape and size. And of course, I'm freehanding, so it's not going to be exactly the same shape and size, but it's going to be close. We split it in 2, so that gives me shaded piece 3, shaded piece 4. Well, I still need 3 more, so draw another figure. So another figure that's the same shape and the same size. That gives me shaded piece 5, shaded piece 6. Well, I still don't have 7 shaded pieces, so I need to draw another figure that is the same shape and size. I'm going to split it into 2 pieces, and I'm going to shade one of them. That's my 7th piece. So this is 7 halves, 7 out of 2, okay? And notice we definitely have more than one whole figure. So I'm going to give you like a little food for thought, we'll say. Is there another number that could be used to represent this picture? And hopefully you're at home shouting, yes, okay? And that leads us to part C. So just kind of ponder this for a moment, and then we're going to draw a picture to go with part C and come back to this question. So part C, we want to write or draw a picture that represents 3.5. So we need 3 whole figures and then half of another figure, okay? So I'm going to go ahead and just use my regular rectangle. So I've got 3. So I need to draw 3 whole figures. So they're both split in half, or they're going to be split in half, both pieces shaded. So that's 1 whole, 2 whole, 3 whole, and then I need half of another whole. So this right here is 3.5. And assuming I had pulled out a ruler and I had measured these rectangles from part B and part C, what would you notice about these images? So again, assuming I'm an artist or I'm a computer program that could have made these rectangles exactly the same shape and size and split them exactly in half, what do you notice about these 2 pictures? Well, this is the same picture that we drew in part B. So what does that tell you about the answers or the numbers in part B and C? It should tell you that they're the same, okay? So 7 halves equals the same exact picture that 3.5 equals. So this tells us that 3.5 is equal to 7 halves. And we're going to address this situation in a future video. Now, remember, when we first introduced mixed numbers, we were like, hey, mixed numbers are just another form of an improper fraction. So mixed numbers are just a different way to represent an improper fraction. So we can convert between the 2 of them. So for every improper fraction, there's going to be some mixed number equivalent. For every mixed number, there's going to be an improper fraction equivalent. And we've got an example of it right here. Now, last up for this video, let's look at plotting numbers or fractions on a number line. This gets a little bit messy if you're trying to plot multiple numbers on a number line. So bear with me, I'm going to use different colors so you can see it. But for part A, we have -2/3, 1/3, and 4/3. So let's go ahead and just start with -2/3. And I'm going to continue to use black for -2/3. We'll switch colors for the other 2. okay? So 2/3 is proper, meaning it's going to have a value less than 1. The numerator is less than the denominator. So when I'm looking to plot 2/3 on a number line, I want to look between 0 and -1. Negative because 2/3 is negative. And what I'm going to do with this region right here is I'm going to split the region from 0 to -1 into 3 equal size pieces. All right, so what that means is this right here, the first little tick mark is -1/3. The second tick mark is -2. Whoops, I'm going the wrong direction. Don't write that down yet. Now you can write down what I'm going to put. So we have this first tick mark is -1/3. The second tick mark is -2/3. And this third tick mark that falls exactly on -1 is -3/3. So -3/3 would be 1 whole. Now we're interested in plotting -2/3. So I would just darken a circle for that value right there. Okay. Now for the next one, let's go red. So the next fraction we want to look at is 1/3, +1/3. It is a proper fraction, so it's going to be somewhere between 0 and 1. So I'm now looking between 0 and +1. And because the denominator on 1/3 is 3, I want to split this region between 0 and 1 into thirds. So I have 0, and then I have 1/3, 2/3, and exactly 1 is 3/3. Now I'm interested in plotting 1/3. So I plot it and just make sure I'm going to circle it so we know that's what we're plotting. So that would be 1/3. Now the hardest one here, we're going to do it in green, is going to be 4/3. Now 4/3 is definitely an improper fraction, okay? It's improper because the numerator is greater than the denominator. So that tells me right off the bat, it has a value greater than 1. So kind of up in the air, I'm going to look from 0, let's say, to 2. Okay, so I've got 0, I've got 1, I've got 2. And because the denominator on 4/3 is 3, I'm going to split the region from 0 to 1 into thirds, so 3 equal size pieces, and then again from 1 to 2 into 3 equal size pieces. And let's sort of count these out. We want to get to 4/3. So this is just 0, and then we have 1/3, 2/3, 3/3, 4/3. This would end up being 5/3, and 6/3. 6 divided by 3 is 2, so that makes sense that 2 would be 6/3. So we're interested in 4/3, which is going to fall right here. Okay, so that's plotting fractions on a number line. It's not always the easiest thing. This is a little bit difficult too because we have 3 fractions on the same number line. If you have 1 fraction on one number line, that's not too bad. But when you have multiple fractions on a single number line, it gets a little wacky. So let's do it again. Let's practice one more time with part B. So my first fraction, -1/4, I'm going to do that one in black. So 1/4 is proper. That means it has a value between 0 and 1. In this case, because it's negative, though, it's going to have a value between 0 and -1. And because my denominator is 4, I want to split the region from 0 to -1 into 4 equal size pieces. So we're going to go from 0 to -1. I'm going to split it in half and then each half in half. So this is -1/4, -2/4, -3/4, and -4/4. So 4 out of 4 would be 1. Okay. Now I'm just interested in -1/4, so I would darken that first tick mark. So that represents -1/4. Okay. Now -8/3. Definitely improper. 8/3 is improper. So it would be greater than 1, or in this case, it's going to be somewhere between 0 and not -1, something beyond that. So there are a few ways to do this. So let's go ahead. We're going to do this one in red. So let's go ahead and kind of above this number line, we're going to look from 0 to 1, 1 to 2, and then 2 to 3. Okay, but negative. So 0 to -1, -1 to -2, -2 to -3. Now my denominator here is 3, so I want to split each of those regions into 3 equal size pieces, then we'll count off until we get to 8. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is like 9/3, -9/3. And if you think about it, -9 divided by 3 is -3. So that kind of makes sense that would fall there. This one was -6/3. -6 divided by 3 is 2. That makes sense. And this one ended up being -3/3. Well, 3 divided by 3 is 1, so -1. Okay, so let's count off until we get to 8/3. So we have 0, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. So I'm going to drop this down to the actual number line, and this is -8/3. Okay. Now, one more, let's look at this one in green. So we have 5/2. This is positive, so we're going to be somewhere between 0 and something to the right of that. 5 is definitely greater than 2, so we're definitely going to be bigger than 1. So what I'm going to do is I'm going to look at the region from 0 to 1, 1 to 2, and then 2 to 3. Now, because my denominator is 2, I want to split each of these regions into 2 equal sized pieces. So from 0 to 1, I want a halfway point. From 1 to 2, I want a halfway point. And then from 2 to 3, I want a halfway point. So that's going to be like here, here, and here. So let's count. Let's see what we get here. So we have 0, and then we have 1/2, 2/2, and 2 divided by 2 is 1, so that makes sense. 3/2, and then 4/2, and 4 divided by 2 is 2, so that makes sense that that would land on 2. Finally, we've got our 5/2, and then we also have 6/2, and 6 divided by 2 is 3, so that makes sense. Now, we were interested in +5/2, so that is right here. So there you have it. That is visualizing fractions. Make sure you definitely understand how to draw a picture to represent a fraction. Make sure if you have a picture, you understand the fraction that goes with that picture, and definitely understand how to plot numbers on a number line. Again, it gets kind of messy, like you can see here. It gets kind of messy when you're plotting multiple numbers on the same number line, but just do it gently, easily, clean, be neat and organized, use different colors if you need to. Okay.